Hello friends, myself Rajendra Mahajan presenting my video on problems or examples of Laplace transform based on more than one theorems. Example, find the Laplace transform of the following. All this example, total 6 examples I am discussing in this video containing more than one theorem. First one, e raised to minus 4t integration from 0 to t cos of 3t dt. Find the Laplace of this. Second, integration from 0 to t of t e raised to 4t into sin 3t dt. This is the second example. The third one, integration from 0 to t e raised to minus 2t sin 3t divided by t and its integration with respect to t. Fourth one, e raised to 2t into integration from 0 to t of cos square t dt. Fifth, e raised to 2t integration from 0 to t of t sin t and its integration with respect to t. And last one, e raised to 3t integration from 0 to t of t into sine hyperbolic of 2t with respect to t. Therefore, this total 6 examples I will discuss one by one in this video. Therefore, starting from the first, find Laplace of e raised to minus 4t 0 to t of cos 3t dt. Therefore, when we try to solve it, we go from right to left direction. Therefore, in this example, first we find the Laplace of cos, then integration, Laplace of integral, and then first shifting theorem in this sequence. Therefore, we know that Laplace of cos of 3t, as per the standard result, it is s divided by s square plus 3 square, and we call this as a bar of s, say. This is the first step. Then we go for the theorem of integral, Laplace of integral. Therefore, Laplace of integration from 0 to t of cos 3t with respect to t as 1 by s into f bar of s. And therefore, substituting value of f bar of s from the previous step, it is 1 by s into s divided by s square plus 3 square. This is the second step, and we call this as new f bar of s, say. S get cancelled, it is 1 upon s square plus 9 as new f bar of s. Here second step is completed. Then in last step, as it is multiplied by e raised to minus 4t, it becomes a problem of first shifting theorem. For applying that first shifting theorem, we get Laplace of e raised to minus 4t into integration from 0 to t of cos 3t dt as replacing s by s plus 4 in the previous result. Therefore, f bar of s plus 4, and therefore final answer is 1 upon s plus 4 whole square plus 9. Therefore, Laplace of e raised to minus 4t integration from 0 to t of cos 3t with respect to t is 1 upon s plus 4 whole square plus 9. 3 square means 9. A required answer. Therefore, we are applying two important theorems to find the Laplace of this given example. Then we go for the second. Find Laplace transform of integration from 0 to t e raised to 4t and sin 3t. Therefore, we go from right to left direction. Therefore, first we find Laplace of sine, then multiplication by t, then first shifting theorem, and then Laplace of integral in this sequence. Therefore, we know that Laplace transform of sine of 3t as 3 upon s square plus 3 square. It is f bar of s, first step. Then we multiply by t, therefore using that theorem, multiplication by t raised to n to f of t. Therefore, Laplace of t sin 3t as minus 1 raised to 1, power s t is 1 here, and same order derivative with respect to s of f bar of s. Substituting the value of f bar of s, we get minus d by ds of 3 upon s square plus 9, 1 by x, its derivative is minus 1 by x square. Therefore, it is minus 3 upon s square plus 9 bracket square into chain rule. Derivative of s square with respect to s is 2s. Minus minus it becomes plus 6s divided by s square plus 9 bracket square as f bar of s. Then first shifting theorem, applying first shifting theorem as it is multiplied by e raised to 4t. Therefore, by first shifting theorem, Laplace transform of e raised to 4t, that term is e raised to 4t multiplied by the terms t into sine of 3t as it is multiplied by e raised to 4t, therefore replaces by s minus 4. Therefore, f bar of s minus 4. Therefore, in that previous step, replacing s by s minus 4 throughout, we get 6 into s minus 4 whole divided by, in bracket, s minus 4 whole square plus 9, and that bracket complete and its square. Here the third step is completed. Then finally, as it is inside the integral sign, therefore we apply Laplace of integral theorem. Therefore, lastly, Laplace transform of integration from 0 to t of e raised to 4t into t sin 3t and its integration with respect to t as 1 by s into f bar of s, finally f bar of s. And therefore, substituting value of f bar of s, we get 1 by s multiplied by 6 s minus 4 in bracket divided by s minus 4 whole square plus 9 and bracket square as a required answer of this second problem. Therefore, watch the video up to end for the better understanding, complete understanding of each and every example. Like as well as hype of it. Third example, Laplace transform of integration from 0 to t of e raised to minus 2t sin 3t divided by t and its integration with respect to t. Therefore, again from right to left direction, first we find Laplace of sine, then division by t, then first shifting, and then Laplace of integral. Therefore, Laplace of sine 3t as 3 upon s square plus 3 square f bar of s. First step is completed here. Then Laplace transform of sine 3t by t division by t theorem. It is integration from s to infinity of f bar of s with respect to s. Substituting the value of that f bar of s, therefore it is integration from s to infinity of 3 upon s square plus 9 and its integration with respect to s. 3 we take outside the integral sign. Integration of 1 upon x square plus a square is tan inverse of x by a, here it is s by 3, and whole divided by 3, limit from s to infinity. 3 get cancelled, and subtracting the upper and lower limit, we get tan inverse of infinity minus tan inverse of s. Value of tan inverse of infinity is pi by 2 minus tan inverse of s by 3. Pi by 2 minus tan inverse is nothing but cot inverse. Therefore, it is cot inverse of s by 3. Then, applying first shifting theorem. By first shifting theorem, Laplace transform of e raised to minus 2t sin 3t divided by t as replacing s by s plus 2, therefore f bar of s plus 2. Therefore, it is cot inverse of s plus 2 whole divided by 3. S plus 2 whole divided by 3, and new f bar of s, say. And then last step, Laplace transform of integral from 0 to t of e raised to minus 2t sin 3t divided by t with respect to t as 1 by s into f bar of s, and therefore the final answer is 1 by s into that value of f bar of s. Here it is cot inverse of, therefore 1 by s multiplied by cot inverse of s plus 2 divided by 3 as the required answer. Therefore, if we go step by step like this, then only you are able to get the correct answer. Therefore, read all the steps once again carefully for all these examples. Fourth example, find Laplace of e raised to 2t integration from 0 to t of cos square t dt. Again from left to right, so right to left, first we find Laplace of cos square, then Laplace of integral, and then first shifting theorem. Therefore, Laplace of cos square t, directly we are not able to get it, therefore we have to rewrite it as 1 plus cos of 2t divided by 2. Therefore, Laplace of this 1 by 2 constant outside. Laplace of 1 is 1 by s, and Laplace of cos 2t is s upon s square plus 2 square, that is 4. And we call this as f bar of s. Then Laplace of integral theorem, applying that theorem. Therefore, Laplace of integration from 0 to t of cos square t with respect to t as 1 by s into f bar of s. Therefore, it is 1 by s multiplied by 1 by 2 in another bracket 1 by s plus s square by 4. Then taking 1 by 2 outside and multiplying 1 by s inside, we get 1 by 2 times 1 by s into 1 by s, it becomes 1 by s square plus s's get cancelled in second term, 1 upon s square plus 4 and new f bar of s say. And then finally first shifting theorem, Laplace transform of e raised to 2t into integration from 0 to t of cos square t dt as replacing s by s minus 2. In that result, previous step result, therefore we get 1 by 2 inside bracket 1 upon s minus 2 bracket square plus 1 upon s minus 2 bracket square plus 4 as the required answer. Here that fourth example is completed. 2 remaining, therefore we go one by one. Fifth, find Laplace of e raised to 2t into integration from 0 to t of t sin t with respect to t. Again, we go from right to left direction, means first find Laplace of sin t, then multiplication by t, then Laplace of integral, and finally first shifting theorem. Therefore, Laplace of sin t as 1 by s square plus 1 f bar of s. Then as it is multiplied by t, therefore Laplace transform of t into sin t, applying that multiplication by t raised to n theorem. Here power is 1, therefore minus 1 raised to 1. First order derivative d by ds of f bar of s minus d by ds, f bar of s is 1 upon s square plus 1. It is minus derivative of 1 by x is minus 1 by x square. As per that, it is minus 1 upon s square plus 1 bracket square. Chain rule, derivative of s square is 2s. Minus minus it becomes plus. Therefore, it is 2s divided by s square plus 1 bracket square, a new f bar of s. Then Laplace of integral, next step. Laplace transform of integration from 0 to t of t sin t dt as 1 by s into this f bar of s. Substituting value of f bar of s, therefore it is 1 by s multiplied by 2s upon bracket in bracket s square plus 1 bracket square. So that s's get cancelled, we get 2 upon in bracket s square plus 1 bracket square as another new f bar of s. And then finally applying first shifting theorem. Laplace transform of e raised to 2t integration from 0 to t t sin t dt as f bar of replacing s by s minus 2. We get final answer as 2 upon s minus 2 bracket square plus 1 bracket close and its square as the final answer. And then last example, find Laplace transform of e raised to 3t integration from 0 to t of t sine hyperbolic 2t. Again, from right to left, first we have to find Laplace of sine hyperbolic, then multiplication by t theorem we have to apply, then Laplace of integral, and finally first shifting theorem. Therefore, Laplace of sine hyperbolic 2t, as per standard result, it is 2 upon s square minus 2 square with the condition s greater than 2, and we call this as f bar of s. First step. Stepwise marking is always there if your initial steps are correct. Then Laplace transform of t into sine hyperbolic of 2t minus 1 raised to 1 d by ds of f bar of s it is minus d by ds of 2 upon s square minus 2 square, it is minus 2 integration derivative of 1 upon s square minus 2 square is minus 1 upon s square minus 2 square and its square, and chain rule, derivative of s square is 2s, therefore minus minus become plus 4s divided by s square minus 4 bracket square, a new f bar of s. And then final step, last step, applying first shifting theorem, Laplace transform of Laplace of integral first, and then finally first shifting. Therefore, Laplace of integral from 0 to t of t sin h 2t dt as 1 by s f bar of s, 1 by s f bar of s is 4s divided by s square minus 4 bracket square, so that s's get cancelled, we get 4 upon s square minus 4 a bracket square, new f bar of s. And then finally applying first shifting theorem, we get Laplace transform of e raised to 3t integration from 0 to t of t sine hyperbolic 2t with respect to t. Remember only this point, we have to go from right to left direction to decide first, second, third, like this. Therefore, f bar of s minus 3, replacing s by s minus 3 in the previous result, it becomes 4 upon s minus 3 square minus 4 bracket square as a final answer. Please like my video, share it, as well as hype the video, subscribe to my channel and press the bell icon to receive the notification of such type of new videos. Thank you. Thanks for watching.